Hello, I'm currently learning Ansible and Terraform and I'm just in the beginning stages. I read some documentation and I thought about a little project I can do to understand it better, and I think it already worth sharing what I learned because maybe later I forget the easy entry parts. So the idea is to provision a system with Terraform and then use Ansible to set it up properly, install the software, do the networking, and so on if something like this is necessary. And my idea was to spin up a server for GNS3, that's a network emulation software that I really like, and I already deployed it several times manually, and it takes a little bit of time to do this, and I thought it would be a great idea to automate this. So I thought about where to do this, and obviously I could do it at AWS or at Azure or something, but my idea was GNS3 itself spins up virtual machines, so it's nested virtualization. You have a GNS3 VM, and in it you run other VMs. But I thought it was cool if you can do it bare metal on a real server. And there are a few providers, or let's say there are a lot of providers that offer bare metal servers on a monthly basis, but only a few providers that offer this on an hourly basis, because I think it's not that easy to quickly provision hardware servers. And one of them is Scaleway. I'm not affiliated with them. I just thought this would be interesting because they have a good documentation about the API, and they are not as big as the really big players, but they already have a lot of products. And one of them is this bare metal, elastic metal, with different tiers. And this tier, for example, would be good for home labbing, I think. If you see this, for example, you have to pay attention that you don't have a spinning disk. But this, for example, you have 192 gigabytes of memory, 6 cores, and 2 terabyte SSD, usually only one available because of RAID 1, and it costs 0.263 euros an hour. So I think it's affordable if you just want to spin up a lab for, let's say, 8 hours or something. That's really something you can afford. But for this video I wanted to go a little bit crazy, but I just saw they launched a new tier here, and this one has 16 cores and 128 gigabytes of RAM and NVMe disks. And I think for GNS3 it's really important. The CPU, it's sometimes important, but usually you have your virtual machines, you spin them up, and then the CPU utilization is really high for a short period of time when everything boots, and then not a lot of traffic is flowing there, so it's pretty much idle. But the disk is really important. If you do a lot of configurations and commits and so on, then this fast storage can really help to fasten your lab experience. And this costs a little bit more, as you can see here. So how can we go about it and provision this virtual server? Obviously, I could just log in with my account and then go through the graphical user interface and so on, and order the server on an hourly basis. But I wanted to do it with Terraform, as I said. And to do this, we go to the provider that is to the Scaleway provider. There is also an Azure provider or AWS provider, or for a lot of cloud services there are providers, and what they do, they communicate with the API from Scaleway, for example. So they communicate with the underlying API without us having to know the exact API calls we have to do. And depending on the provider, there's different documentation, but this one is pretty good, I think, that you can see here. Okay, what do we want to have? Do we want to have a database? No, but we want to have this elastic metal thing. And there we can see under resources that there is a Scaleway bare metal server, and there is a basic configuration, and I pretty much use that. If I now open this Terraform file, you can see here is my real Terraform file. I used to provision the server, but I didn't want to show my API key, although it's deleted when this video is published. But I wanted to show this. So first of all, you have this provider Scaleway, and you can give the organization ID. You can get the organization ID in the web interface or via API, and then you have your access key, your secret key, that is your password, so you can authenticate against the API. And then you have the project ID for the current project you're using. You can separate your servers into different projects with Scaleway. And now the most important part is the Scaleway bare metal server. This is here, you can see it, that's just a product. And then how I call the server. So you can reference this later with some dot notation. Then I give a name for the server, but before I do this, I want to show you the real API documentation, because this can be helpful to know what is required at this point. So we need an offer ID, a project ID, a name, and a description. So maybe you think a description is not necessary, really. Yeah, it's necessary. So we have to provide this to the API and also to Terraform then. So I gave my instance a name. Then I provided a zone. The zone is Paris 2 in this case. I chose the one where this offer is available. And then I have to use the offer. And for this it's a little bit more complicated, because you have to read on this API documentation how to do an API call to get the offer IDs. And you can do this with curl later, but to show this a little bit better, you can do the API calls with this software here. You can also you can get your project and your SSH keys. I don't want to show this here. That's just a API request where you can get the IDs for all your SSH keys you have on your profile. But what I now want to do is to query the offers that are available with Scaleway. So I send this to this API endpoint in this region, France, Paris 2, and get the offers. This request is authenticated, so I have I set my secret key here so I can get this information. So here you can see the different offers, and because NVMe is pretty unique, I can search for this and I can find this offer I'm looking for already. It's the same one we saw on the page previously. We are looking for this ID. And you can also see everything else here. The capacity of the NVMEs, then the CPU cores and threads, and the memory if it's EEC, and how much it costs. But there's one really important thing you should care about, and I think this also applies to other vendors, is if you're ordering hourly or monthly. Because if you check here the next, for example, the Windows 2019 data center, it cost 286 euros, and the subscription period is monthly. So you have to make sure that you really use the hourly offer and not the monthly offer for this, because you had to pay more, unless you really want to do it this way. But I think for my experiment now, you usually don't want to do stuff like this. So I copied this ID and pasted it here to the offer. Now I have to find the operating system. Before that, maybe you noticed that here was a field incompatible US IDs. So there are some operating systems which are not compatible with this offer. For the lower bare metal servers, for example, with low memory, Scaleway doesn't offer the operating system Proxmox, for example, because they think it doesn't make sense to install Proxmox on a low memory machine, for example. But we now have to query the operating systems. And there is also in the API documented how to get the operating system IDs. I sent this also authenticated. And then I have all the operating systems here. Luckily, our operating system, or the one I want to use, is at the first place already. It's Ubuntu Jammy Jellyfish, and I can copy this ID. I can go back to my other query and check if it's not supported, for example. If this ID, what I'm now copying, is not supported, but this one is supported, so I can paste it here. Then I have this description, which is mandatory, and I can give a host name, and I can provide SSH keys that should be able to access this server. I could also add other, for example, a user and a password, but I left it to the default values that the user is Ubuntu. So this is everything that was required to spin up the server. So how this works with Terraform is now that you first say Terraform, you can maybe see here in this folder there's currently no other file or folder in it. And then you go Terraform init, so you initialize this. Oh, I'm in the wrong directory. I initialize this, and then you can see that there's a new folder and a new file, and one of those files is the Terraform provider for Scaleway. Because if you make this autocomplete here, resource, then you get the information here. It's easier to write this stuff. If you, what do I want to have? I want to have a bucket, S3 bucket or something. So it has autocomplete and you can easily write this stuff. So the next thing would then be to spin it up, and this works with Terraform apply, and then it asks, should I really run this? So there's another confirmation. For example, it could say, do you really want to spin up those 120 instances? And then you obviously say no, or maybe you won't, I don't know. Yeah, so it needs a confirmation, and then you can spin it up. And in my experience, I already did this, and it took 20 minutes. You might think if you sit in front of the PC, it's a long time, but I think for provisioning a real hardware server, it's a good time. So the server is provisioned. You see that everything is local. If you check now system ctl status GNS3, nothing is there. Or if you check IP tables, it's all the default values, and nothing is yet installed. And for this, we now use Ansible. And now we have to know stuff about GNS3 and how it's installed. So I knew this already, so I could do the steps and adapt them from what I did manually before. So if you're interested, this will take a little bit longer. If you're just interested to see how GNS3 looks like, you can skip this part, but I want to show what everything means in this playbook. So Ansible has a playbook, and usually if you go by best practice, you also have a directory structure with a lot of components and files. So I'm not using this here for this experiment. Everything is in one file. It's relatively short. So just the hosts, I have separated this in two parts. This is my main hosts, and this is the test host I used for testing. Usually in this file you would say, this is my front end, this is my back end, and then depending on in which category it is, you apply different steps in this case. But I apply all the steps just to set the server up. So the first one is the name for the playbook, then the host, in this case is main, so I want not to use the test, I want to use main. Then I have my remote user, which is Ubuntu. Become yes, but means that it uses sudo to gain root access. It's allowed to do that. The requirement for this is that you don't have to type a password here to gain root access. You have to make sure, or you have to provide the password here or in an environment variable. The next step is, I like to do it this way because I can see in every step what's happening. It would also be possible to do this in one step, to install new packages with apt and also update the cache. But I, just for my experiment here, did everything in one step so I can see what's happening and if anything fails. So this equals apt update. Then I install the prerequisites that are needed to do the next step, except this, that's just for fun. But I installed this manually on the server before, so this will not be installed again. Ansible will know that it's already installed and skips it. And then I do a really, really dirty trick that I wouldn't recommend you doing, because this GNS3 instance, it has all ports open to the internet. And if you spin up a virtual machine, it's reachable with a port. You can telnet to it and so on. So I had to find some way to limit the access to the internet, and a good way to do this is obviously by using a firewall, or you use a jump host and you make the GNS3 instance only available on a private network, or you bind the GNS3 server to a local host and then a VPN into the server or something like that. But I did a quick and dirty trick with IP tables, which is not very reliable, I think, because on this host is also Docker and virtualization and other processes add IP tables to it. So this is something I wouldn't recommend doing, but maybe it's interesting for you what I did here. So first of all, I added an IP tables policy that allows related and established traffic. That means if I now ping from this machine here, this IP, then it's by default allowed to go out, but the reverse traffic is blocked later with the policies I set up. So we need a way that the related traffic is allowed. If I ping this, the ICMP reply that comes back is also allowed. So this is what this part is. And the interesting part for the Ansible stuff is that we can use a variable here that is dynamic. So Ansible gets information from the hosts, and you can use this in variables. Yeah, you can see this here, for example. I did this. This is not the exact same host, but Ansible has access to a lot of information once it connects to the host. And for example, you can see here Ansible environment, or what's more interesting, date and time, links, devices. Yeah. You can see a lot of information about the system. For example, here, Ansible distribution, Ubuntu, and distribution version. You can all get this and reference it in the playbook file. So this is what I did here. I reference the interface, the default IPv4 interface, so that this can be blocked and allowed later. So in this step, we allowed the return traffic for stuff we established from internally. Then in the next step, we say only my IP from this variable here that I defined. That's my source net IP from my internet provider. So only this IP is allowed to connect to the server. And the next step is everything else that comes in the input chain for this interface only gets dropped. So this is why this is dangerous, because if this fails, if there is another interface or something, or then every traffic is allowed. So it must be the right interface, it must be the right IP. There are a lot of stuff could go wrong. But this is just, if you want, let's say for a day, spin up your server, then there is, it's an okay method, I think, to do it this way, but it would be better to put a firewall in front of it or do a jump host. The next thing is that we add a user, and maybe at this point I can tell about this Ansible built-in. You see here user. Before we used IP tables, or we used shell here. We used a shell command to make the IP tables persistent, so they are all they survive a reboot. And here we use user, and there's also documentation when we can search for it by with Ansible, and we can see what fields are allowed here. For example, I set the home directory for this GNS3 user to opt GNS3. This also creates a folder, and I set the shell for the user. If we go back to the here, we can see check which users are on the system, and we can see if we check here, there is no GNS3 user yet. So we haven't run this thing, so nothing happened, what we are talking about here. So then we create a unit file, and the unit file is just for the GNS3 server that we can control it with system. Here you can system status GNS3 couldn't be found, and yeah, so that's not there. This is why we want to copy this to the right location. The next one is that we want to copy the GNS3 server config, and the important part here is to which IP we bind the GNS3 server. As I said before, you could also bind this to localhost and then have a better security concept, or you can change the host, and here you can change the path, but I left it the same as the official VM uses it, so that there is no weird surprises. The next one is that I add the key for the repository, for the GNS3 repository. This is the legacy method because it will complain once I hit apt update later. I did it the right way with the Docker, but just wanted to test this one. Then I do an upgrade, which means all the software gets upgraded on the target system. And then I install GNS3, here GNS3 server, and Tiger VNC for the VNC sessions, which is required. And then I install Docker. And this is basically, if you go to the Docker installation steps for Ubuntu, you can see here there are some steps you need to do to install Docker on a system. And it's basically this just in Ansible. So you can see here, it's some here apt install, CA certificates, and so on. This was already installed. And then I get the signing key and install or copy it to the right location. This pulls it from the internet. And then I add it to the file. Maybe you know from, if you go to, then there is a sources list where all the sources were the repository, where new software, and there's also this directory which is currently empty where you can do similar things, and this is just to update this with the GNS3 repository, with the Docker repository in this case. And then after this is finished, I can install everything Docker related. And if everything finished, if we install GNS3 and Docker, we can add the groups to the user, ubridge docker kvm, and that just means that the GNS3 user is allowed to read all network traffic and is able to spin up new virtual machines and Docker containers and so on. And at last, we enable the service if it's not already, and start it if it's not already started. So, and how we do this now is by using the command, I clear this, Ansible playbook. Oh, I'm again in the wrong folder. We use the command Ansible playbook, and then we specify the host file. I think there is no convention how to call it. And then we do one V for verbosity, just to entertain us in the next minute. And then we say the playbook. For example, for testing, I had a testing playbook here. Then we can say test.yaml, but this file you see here is now playbook. And when I execute this, then I'm asked to first connect to the server. This is okay, it's the right IP. And then everything begins. This now takes a little bit, but maybe we can make it a little bit more interesting if we also open htop here and see, oh, this looks good. See the utilization when something happens. For example, yet now we do the apt upgrade and now we install GNS3, so a little bit should happen here while this downloads and installs. This should take the longest. We can see what's happening here a little bit. And while it's doing that, okay, now it skips, we can't see it anymore. Everything was installed. But you can see here, every step I had here is now, you can see it here, Docker and Docker signing keys, and now we install Docker. And now we enable GNS3 as system service. And when we now check system control status GNS3, we see it's running. So everything is installed. That's pretty cool. And then we can test it now if we can open GNS3. And now you can, if you don't know it, you can see it now and can tell a little bit about it. It's now connected to my test server locally here. And if I go to preferences, I can go to server and you can see this is a local IP. But what we now want to do is connect this with this host. So with this thing we just installed. It's the same port as we saw before. And then we hit OK. And this is now new. I restarted once because I had problems once with the repository after I changed the server. But now the right server is selected here, GNS3. You can see the host name here. And now I make a new project, testing. And I can do very basic stuff here. For GNS3, for example, I can do here NAT for internet. I can do a switch and 2 PCs. Everything of those steps you could obviously do easily on your own PC because it doesn't require a lot of processing power. And then you could, for example, do, you start this and also start this. And then you say, you start a packet capture. And this starts Wireshark. How do we do it? And now, if I open this, you can see here in the terminal, I can see from PC2, I want to do DHCP now and get an IP address. This is NAT magic here. And then you see here, you can see the traffic. DHCP discover, offer, request, and ACK. So you can get a very good impression about what the network is doing here. But it's even more advanced. So if you're interested, I will show it. Now, did I close it? Okay, let's do it again. What did I use for this? Yes. So we go to root. I try to do it a little bit. This is not mobile friendly, this video, but I'll do it a little bit larger. So I downloaded one image before. If you see here now you can see preload, and you can see that I have downloaded the Kali Linux image. I decompressed it, and we can now move this image to opt GNS3 images chemo And then we go to this directory, and we can see that we added this image to the GNS3 directory, and then we have to give it the right user. So this is now owned by GNS3, but now maybe you can see a little bit of the power now. If you now manually create a new template and you go to QEMU, then you do a new device, and then we give it, I don't know, we have enough, and then you set it's VNC, and now it's getting the information which images are on the server. It takes a little bit too long, unfortunately. So, yeah, it took too long. And now we get it. And I press finish, and I edit it again, and I give it 8 CPU cores, and I can do some other settings here now. Okay. Okay. And what we can do now is have a Kali Linux. We just drag and drop 2 of them and connect it to the switch. And then we start it here. And we can see how it boots. We can also start the second one if we want. And can also connect to it. So you can imagine that this could also be routers or firewalls or something. Now we can log in. And we have a virtual machine. Obviously, you can also do networking so that you can access it in other ways. And then, for example, you can do stuff with Docker also. If we manually create a template, let's say Docker, and we want to have Nginx, that is from Docker Hub in this command. And it can be telnet, finish, okay. And what it does now, it pulls it from Docker Hub. If I drag this on here, you can see that it's now pulling. And then we can connect it to our network. And we can configure it so that it gets a DHCP address. So we can also give it a static address. Select OK. And then go start. And we can do a captcha here. So we can check, do we see an IP address here? We can see this one. Maybe we can start it again. If we stop it now and then start it again, then it should do traffic again. We can see here is now the IP address, and if we go now into Kali Linux, for example, in the browser, then we should be able, oh no, keyboard, I'm German. No, I think I did a mistake. Maybe it works this way because I have to change something in the settings of the VM first from the GNS3. What did I say is the IP? Then we can here see that this is the Nginx default page that is here. So we can do a lot of stuff here, and I think my next project will be, as you can see here, I have to add those templates. You can also have templates that are updated from the GNS3 servers, but you have to download them. Some of them are proprietary. You can't just download them somewhere, but some of them, like OpenWRT or something, are open source. So I think my next automation project will be that I already copy all the relevant information, and if I go through the terminal here and go to, where is it? No, it's in etc GNS3. You can see that here is the GNS controller conf. And there you can see that there is a configuration for the Kali virtual machine we just added. So we can do this configuration here in a config file and also copy all the machines to the target server. So whenever I start the server, which costs in this case 70 cents per hour, then I don't have to manually import all the firewalls and routers I want to use before. So this makes my life also easier and cheaper maybe. Yo. This was my first Terraform and Ansible experiment. Maybe it was helpful for you too. If you want to destroy the machine again, if you want to stop it, you can go to your Terraform and in the right directory then Terraform demo, and then you would say Terraform destroy, and then everything that is referenced here, so this is an easy example, there could be 50 servers here, will be destroyed if you press this and then confirm what gets destroyed. Also, if you just want to change something, let's say you want to change the name or you want to change the description or something, then you can write Terraform apply again. This is especially useful not with the bare metal server, but with other VMs where you can dynamically change or add disks and so on. Yeah, that's all. I hope this was a little bit interesting. Oh, it took way too long. Okay, bye. See you.